I think I better start with the disclaimer, okay? A lot of the things we're going to talk about and a lot of things that we're trying to get a handle on are ways away from application. But I do think it's really important to give y'all an idea of some of the things that we're trying to look at as we go forward, because every one of you in this room know it's getting more difficult every day. We have weather challenges, input costs rising. It's just getting to be tougher and tougher. So when they asked me to participate in here, part of the subtitle was focused on efficiency. Some of the things that we're focusing on in some of our research in the Ag Division is looking at individual animal efficiency. And I think that certainly has a place. But don't for a minute think that I'm going to tell you something on an individual animal basis that's going to impact the same type of efficiency or a similar efficiency measurement on a herd basis. It goes into that. We certainly may be interested in it from a genetic selection perspective, and we're interested in it in a measured response perspective. But don't forget the things that make you money in the cow-calf business, right? She better calve, I better wean a calf, and that calf better be heavy. We can do more than that too, like don't overgraze our native pasture. So this stuff is kind of out there, but I think it tells a pretty neat story, and I hope it's a little hook out there so you kind of stay tuned to what's coming. When you start talking about individual beef cattle efficiency, you might have seen all of these terms: gross feed efficiency, dry matter conversion, residual feed intake, residual average daily gain, and some a bigger numbers better, some a littler numbers better, and I get all confused. I kind of try to make it simple. I got something going in, typically feed or some pasture, and I'm producing some pounds of an output, either it be beef, calf, milk, cow, something. Now that's efficiency I can kind of get my head around. I'm putting something in and I'm growing something. Our problem that we have had historically as an industry is both of these things are inherently difficult to measure on an individual animal basis, right? It's hard to know what that individual cow is weighing out there in the field. It's also very hard to know how much pasture she's eating each day or how much feed I'm putting in front of her. And if we're going to really fine-tune our management systems, and Hugh and Chuck and the others have given you some very good ideas on how to manage some of these pastures, but if we want to take it to a different level, then we're going to start looking at some of these things on an individual animal response. The Noble Foundation Ag Division, we focus a lot of research and effort on forage-based beef cattle production. No surprise. Probably every one of you are involved in that business one way or another, and that's the largest generator of revenue from an agriculture product in our area. So, for example, if I've got these cows on this native range, and we've been talking about native range all day, let's think about that a little bit more. Okay, let's just think about that. Hugh said, a measurement tool I had is just like Kent's holding back there is that forage stick. Okay, that's okay. I get you. I'm with you. But if this is 5,000 acres that I have of native range, I'm not sure I'm going to measure with my forage stick on every piece of that 5,000 acres, right? So how do we get a bigger picture idea? Traditionally, in a research perspective, and they're kind of hard to see, but if you see each of these little yellow dots, that sort of represents a vegetation transect. I'll put a 100-meter transect there, and important times of the year, I'll go in there and see what plant's growing on it and how much of that plant's growing on it, and I get a little representation of what's being produced out there. That works. It's extremely labor intense, and it takes a while, okay? So what else could we do? We're working with some technology that Corey Moffitt brought with him when he came here, called very large-scale aerial photography. Somebody will get in this plane, and if you look closely, you can see some lenses that look like this, and we have 3 separate cameras with different resolution lens that are on a computer. This is the same ranch I showed you before, and we fly this, and each one of these X's, it's programmed to take a picture. Very high resolution picture. Well, that's kind of cool, right? What are you going to do with that? This is 2010, a picture that was taken with kind of the lower resolution imagery. This is 2011 of exactly the same place. So what can we tell? Well, we know that the pond level was here, and it's lower, so it's drier. We know that we ran a prescribed burn through here, so if we look, we can see here in 2010, get an idea of some of this cedar And as you can see, we've killed a few of those cedars. And we can get more of almost a larger land scale of what's happening. Are we controlling eastern red cedar encroachment with that burn? What's going on? We know it didn't rain, so in 2010 there looks like there's more forage than there was post-burn in 2011, because we didn't get enough rain to do a whole lot of good. So what do we do with this higher resolution imagery? This is a higher resolution shot with that long lens camera. Flying at 150 feet altitude, they can take this resolution of photo. So I can identify what forage is there, flying over it, however fast that piece of equipment flies over it. But in a day, I can sample that whole place, each one of those marks. Now, it takes some computer horsepower to analyze this stuff and do these things, but that's one of the things that we're trying to bring together is how could we automate that? And then, you know, who knows, sometime in the future, maybe there's a service that says, it's time to sample my ranch. We fly it back, we tell you what's there, we tell you what's going on. Probably most of us are carrying a GPS unit in our pocket today, right? Crazy. Technology is crazy, but it's coming and it's there. So we got interested in GPS technology quite a while ago, and now we're building our own collars at the Noble Foundation. We got some really smart folks that are programming these chips. What used to be a $3,000 unit, we can build in-house for $300 or $400, $500. So now I've got more tools that I can apply out there. So what might we do with that? Well, we might hang it on a steer. We might hang it on a deer. This would probably increase my hunting success, but that's not the use. But there are a lot of questions of what is the interaction on a native range situation. We have huge interest in hunting, right? Hunting's bigger and bigger all the time. The recreational piece of these native ranges is important. But we also want to maximize our enterprises on there, so we still are interested in this steer component. And we get the question, well, I don't want to put that steer on there because it's going to interfere with my deer. Well, just so what if I put one of these on each and I turn them out in a pasture? And if you'll look closely, you see this blue? This was the steer. And this is where this steer is going over a 2-day period. And it's pretty interesting to watch it because he'll travel a while and then he'll stop and graze a while, right? You see him grazing there, grazing here. So think about that for just a moment. And I have that high resolution imagery when I can almost say, wonder what he's stopping right here and spending time on. I might be able to tell you. Kind of cool. Also interesting, this red dot is that doe actually. And remember, this is kind of a mid to late May time frame. And this doe, if you're watching her, she's got a home, doesn't she? You watch this spot right here. She doesn't get too far from this spot. She'll wander a little bit. She doesn't get too far until the steer gets interested and come bumps her. She moves a little bit, she leaves, but then she comes back. That's kind of cool too. There's a lot of things we can begin to analyze and look at, particularly looking at these two species interactions. But you know, that's one use of this technology. This is our friendly map that has X's on it, and so kind of pick out your favorite X, okay? So if we take this GPS technology and I put it on 5 steers and I turn them out typically in a warm season grazing situation on native grass, say April 15, and I let him run until July 15, and I collect, let's say, a point every 5 minutes. What's that look like? Essentially, this is a steer observed every 5 minutes over a 135-day period or so. So we said our favorite X was right in here. This doesn't get a whole lot of use, does it? We might want to wonder why, might want to consider why that may be. This is this whole thing is a big ongoing project that's really looking at the interaction of burning and grazing on the health of native range. Hugh emphasized how important native range health is. So we're burning this. Each one of these different colors you could say is a treatment, and on half of those treatments we're burning a piece of it every year. Well, I think if you look very hard, you could probably tell me where we burn if you think about it. Look how dark this piece is. We burned this the previous year. Look how dark this is. We burned it the previous year. Look how dark this is. We burned it the previous year. It's probably not revolutionary to think that cattle are going to use that fresh young growth, but it sort of validates what we're talking about. Then we get into a year like last year when it doesn't rain so much and we do a prescribed burn, and we also turned up our collars. We're continually tweaking on these collars. Now we get every 2-minute resolution over that time frame, so the colors get darker. And it gets to be kind of interesting to really sit down and think about when I combine all of these pieces of technology what it might be able to tell me. The other thing I think is very interesting is realize that these paddocks are about 600 acres, but there are absolutely places in here that like you said, they're not utilized. So if I figure that number into my grazing acres, I'm making a mistake. So that kind of tells us a little bit about the direction we're going on some of our native range complexes, okay? But we also know that a big component of forage-based beef cattle systems are the stock enterprise, right? Grazing small grains. So it's a little different animal, right? We got a monoculture of a pretty highly managed forage in one spot. We can use that forage stick to measure the forage allowance as well. We can also use this new technology, and I think we got a little short video clip here, about 30 seconds.
The rising plate meter, it consists of a plate 15 inches in diameter, and as you place the plate meter down into the forage mass will push the plate meter up, causing the potentiometer to roll up against these grooves, and then that potentiometer measurement is actually recorded. We can get an instant estimate of what the forage mass is versus having to wait to drive samples. With this, we can take measurements and adjust stocking rates that day.
So that's one piece of equipment that we're using to get a better idea of what actual forage availability might be on small grains. You know, that stuff's expensive. Everybody knows how much it's costing now to put in an acre a week. Russ Gentry, many of you know him, he's our operations guy, makes everything happen. And he told me, he said, you know, it's interesting that we stock small grains pasture the same way today as we did when I got here 23 years ago. And it's sort of that way, right? We sort of have this rule of thumb, 1 calf in the fall and 2 in the spring. Well, if that stuff is costing me more and more money all the time, I want a better idea of what's out there and how I can better utilize that if I'm going to graze it, maybe get a few more pounds of gain. And this is one of the things that we're using to get a better estimation. The other thing, I don't like to walk around and do that a whole lot, so we're looking at automating something similarly, and this is what we call our forage sled, and Corey Moffat's going to tell you just a little bit about it in about the same length video.
Basic design of the forage sled is this fairly large sled, and it runs on fairly narrow tracks that keep a good contact with the soil. This plate, or the foot, is able to rise up and down freely as it goes over the vegetation. The runners are running on the ground, so the difference between those is the height of the vegetation. And he's just going to drive through here and make kind of a figure-8 pattern. We want to be including areas near the fence, out towards the center, up towards where they're being fed, down where the water is, and you kind of just want to cover the entire area.
First tool, and a very valuable tool for you to use, is that forage stick. It gives me a one-dimensional measurement of height. There is a correlation to height and forage available, and then correspondingly reserve herd days or stocking rate. We're trying to get a handle of more of a 2 or 3 dimensional estimation of how much forage is there, so we have a better handle of what's actually there. Because if I want to get an idea of efficiency, now it's one thing to measure the forage, it's a whole lot more difficult to measure what that animal's eating. But maybe if the technology is good enough, I can look at disappearance in some situations and make a better estimation of what's actually going in that animal. So that's a little bit of the forage piece that we're working on, how to get a better handle and measurement on forage. But what about this old steer? You know, as I went to graduate school, however long ago now, sort of the holy grail was individual animal feed efficiency. We thought if we could solve that, we could cure a lot of ills, because we know there's variation within animals. There absolutely is. So how do we start getting a handle on that? Traditionally, if I had this steer and he was on some sort of test and I wanted to know what he weighed, what did I do? I run him through a chute with some load cells, and I measured a weight. I hope I measured a weight at the time he started on a test, or we put him out, and then at some routine time into the future I measured him. So I had a measurement, it looks like here, about every 2 weeks. That represented the cattle gain, right? That's how we measure cattle gain. We weigh steers as we can catch them. What we know is that there's a whole lot of stuff in between here we're not getting a good handle on. So several years ago now, we formed a research agreement partnership with GrowSave International, or GrowSave Systems now. And GrowSave is a Canadian company that really looks at making specialized equipment. And they've been doing this for a long time. And surprisingly, I know to all of you, it takes a long time to adapt technology into the cattle business. Now, that's probably the most profound statement I've made today, but we all know it's true. So it takes a while, but we start working with this company because they offer this piece of equipment that we think is very unique. We have feed bunks, sort of look like typical feed bunks that I can deliver into with a mixer wagon. And this feed bunk is pretty unique in that it sits on a set of load cells. This calf has an EID tag in his ear. When he sticks his head in here, there's a reader in the top of this bunk, and it registered who stuck their head in him. As he eats, it assigns the amount of feed that he eats to him. So I'm getting a very good estimation within about a 10-gram resolution of how much an individual animal is eating each day. That's cool. If you're in the beef cattle research part of the world, that's cool, because that's something we couldn't do previously. We put it all in a trough and we divided it by number of heads, and that was how much individual intake was, right? So we have this technology now that we can apply. They have this other piece of equipment now that we begin utilizing. We're really the only place out there that uses all this technology together. And this is what they call a GrowSave beef unit. What it is there's a water trough that lies in between here. And each one of these stanchions there's a load cell suspended up here. So a calf comes up here, steps up on it with just his front feet, and I get a measurement. And I get a measurement every millisecond. Okay, lots of data. As that calf sticks his head in here, similarly as an intake system, I know who he is and I measure how much water he drinks. So you can think that in a pen that has both of these pieces of equipment, I daily know how much that animal is eating, I know how much it's drinking, and I know what he weighs. You say, well, you're only measuring the front half of the body. True. Our data, the limitation on knowing how good this data is, truthfully, is how well I can measure the weight of an animal on a load cell somewhere else at a full body weight like we usually do it, okay? I have so many repetitions and so much data by using this that we're very, very confident that just measuring the front half of that calf, I know what he weighs and I know what he gains. If we turn this movie on, this is the screen that's in front of, that's hooked to the computer this data is coming through. This represents 4 of those feed intake nodes, okay? 4 of those bunks. When these are green, there's a calf up there eating, and we're assigning feed to them. When they turn orange, there's nothing there. So as you kind of watch this movie, this calf pulled his head out, now he stuck it back, pull it out, stuck it back. And if you watch this over time, the height of this bar disappears because that's a weight that's in each of those bunks. That's kind of cool. You can pull it up on your phone right now and watch it if you get bored. This down here is measuring the water intake of that in that same pen. And essentially, when there's nothing showing, there's no calves on any of those stanchions. There's a calf now standing on this stanchion, and he's drinking. The front half of that body, that calf weighs, I can't read that, maybe 280 pounds, and he's drinking water currently. If we'd sat here and watched this long enough, you'd see him pull his head up and quit drinking, and then you would see it turn that color. Okay, he quit drinking, but he's still on the scale. If he steps off, you'll see it go. So you think about all this data that's being accumulated and stored, it's a lot of stuff, okay? This is, okay, we put a calf on feed in that situation. We're talking about a confined feeding situation, and he's been there 33 days. And this is a variation of intake on that animal per day. He started off at 7 pounds, then 20, then 10. And so what we can absolutely with confidence say is when I put that 750-pound calf in a situation where he has free choice access to the feed we were feeding, he's going to eat somewhere between 7 and 37 pounds a day. This is the same pen for one day for all 32 animals that are in that pen, and look at the variation by animal. Again, each of these bars represent an animal for a day. So within that pen, these animals are eating somewhere between, well, here's our old buddy that was eating less, but you see, when we start looking at data on an individual animal basis, you all know it. You look at your cows and you know she's a good doer. It doesn't take much feed for her to do well. And that old cow over there, she never comes to feed, and she always looks good. What's going on there? We're now getting to a point from a research perspective where we can actually start looking at some of this data, okay? Remember our old buddy traditional data, right? Measure them every 15 days. That's what we based the whole body of work of beef cattle science on. We can sort of replace this with this mess now. This would represent, I mean, this is real data. This would represent that calf's body weight every day while he was on that test. We would do a regression and kind of smooth that line, but instead of some points in time, you see that body weight really, you know, what we thought was plain, growth planes and things like that, we're now able to get a very good handle on. But as you can see, it's not a straight line, certainly. We also have a water intake for that animal and a feed intake for that animal. You're seeing some of this technology now being used in centralized bull tests to start getting an idea of efficiency on individual sire basis, and we're starting to market that in some places. Remember we said the holy grail was individual feed intake? We think now there's a new one, and the new one is individual animal efficiency on pasture. So we want to begin to get an idea of what those animals are doing on pasture on an individual basis, on a daily basis. So we've taken that equipment that was supposed to be in the feed yard, and we put some of these Grow Save beef units out on pasture. We are just getting this started. This is the only place this is going on anywhere. But what I hope you can see is we're combining some unique technologies wherever we can find them to hopefully at some point be able to stand up here and tell you this is something you can do from a management perspective that'll make you more money or save you more money or add to the efficiency of your bottom line for your enterprise. Because in the end, this is what it's all about for us, and we don't forget that. We cut our teeth on helping producers. We're going to help our producers today and then tomorrow. All right, thank y'all.